Hello everybody, I'm Jean-Simon Venne, I'm CTO of BrainBox AI, and I will give you over the next few minutes an update on how we're applying deep learning technology to the energy efficiency sector for buildings. Deep learning is a very transformative collection of tools that are impacting several industries today. But for the real estate sector, it is very, very, very new. Buildings are conditioned with what we call HVAC system, heating, ventilation, cooling system, so it's always maintained at a comfortable temperature. These systems are programmed into reactive, schedule, rule-based systems, which are absolutely not adaptive. Using these deep learning techniques, like neural network, is giving us the opportunity to do self-learning, continuous learning, to predict, to preempt, to deliver autonomous and adaptive system. So how are we applying all this? Well, we decide to follow a strategy, a deployment strategy, which is using proven existing technology used in other industry and to slowly and progressively apply them to the sector we're working in. So if you think about the self-driving car, we're using the same technique of predicting what is the path we will follow, where are we going to be in the near future, and then seeing things coming our way, identifying events that will be happening. We use that information to apply a more preemptive control and optimization in terms of decision where we're taking and a minute per minute. Using computer vision, we are able to recognize thermodynamic events as they are slowly happening, and understanding these events, we know what will be happening next. And what about time series techniques? Like recurrent neural network applied to time series, we follow the same type of a translation analysis, voice recognition technique, but apply with the time series of the thermodynamic event happening in the building. So we're able to predict from time 0 what will be happening at time 1, 2, 3, 4, and 5. So let me show you what it means, the way we're applying it regarding what we define at our own sandbox of application. So existing commercial buildings have a lot of data already available. People paid a lot of money to deploy these control systems, which are generating a lot of data. That data is used to control the building on a real-time fashion, reactive, and then that data is forgotten, overwritten, disappeared, deleted. So the opportunity for us was to tap into that data, use it to generate a lot more value than what it's generating today. So we put together an edge device that connects to the existing HVAC control system, heating ventilation system in building, and extract the data, and then send that data to the cloud, accumulate enough data so we could apply the AI deep learning techniques to generate more value with it, and then in return start modulating the building in real time. So what does it mean? Well, it means that we're moving from that reactive to that preemptively that I keep talking about. And if you look at this example where the temperature in a given room in a building start to rise, and it's becoming hotter and hotter, that's the black line, and then eventually will hit a certain value pre-programmed in the system where the cooling is going to start to bring the temperature back down. And of course, if it worked too hard, or it's too efficient to bring the temperature down, it will bring it too low, as you see that black curve going down, and then it will trigger the heating set point where the temperature is going to be bring back up. So that's what we call a reactive system. In the case where you want to be preemptive and you know what the future is because you apply LSTM, deep learning system into it, well, knowing that future, you could start to apply a different configuration right now to change that future and have a much smoother curve, which is creating less discomfort in the building and saving a lot of kilowatt. So here's an example of how what it does in terms of preemptive. So here's what our AI is doing when it's calculating what is the future. This is a 2-week span, and we're calculating what it's going to be the temperature in a given store, that's a retail store, 2 hours in advance. So as you see, one of the two curves is the temperature with a 2 hour ahead prediction, and the other curve is the real temperature as it evolved during the same period. And I'm going to do a close-up for during 1 day, so you could see the variation in between the two curves is less than 0.1 degrees Celsius, which is below the precision of the equipment, the sensor itself in the room. So with that kind of quality in terms of prediction, knowing the future, we could start to apply different configuration strategy that will transform the thermodynamic of the building in a better fashion. So far, we've been installed this technology in over 40 buildings. Savings on the energy sides are around up to 25%, reducing the carbon emission in between 20 to 40%, reducing more than half of the comfort issue, and all that with an install time of between 2 to 3 hours per building. Of course, the learning time, once you have the data, the learning period is more in between 1 and 2 months, but the involvement of human in the install is only 2 to 3 hours. A couple of results: office building, downtown Montreal, 17 floors, around 21% saving. An hotel in the suburb of Montreal, 43% saving. And an average on the retail space, different stores that it was deployed with savings around 20%. I would like to thank you for your time, and we look forward to meet you in the near future.